Okay, let's get started. So, hi everyone, my name is Florian. I'm working as a software engineer at Facebook. So I'm working in the team called Data Center Products. So we have a few different products in React.js and in React Native. So the idea is to make sure that all the data center and the technicians working in data center can do their job properly, and yeah, that's what we're doing. Before being at Facebook, I was building quite a lot of different React Native applications. So in fact, most of my talk is based on my experience with React Native and building open source modules for it. I'm also the developer and main author of gdevelop. It's a game creator software that everybody can use to create games. It's based on React too. And the idea is that anyone can start the editor, create a few objects, and then create the rules of the game using visual events so that you don't have to program to create your own game. So that's my open source project. Feel free to check it. And last thing is that I've created a game with my game engine, which is called Lil Bub Hello Earth. It's a game where you control a cat going all around the world. That's not a joke. And that's a project that we made with a few friends, including Lil Bub, who is a real cat. And it's a bit like Grumpy Cat, if you know him. So yeah, feel free to take a look. It's also on the Play Store and on the App Store. But let's go back to React. So I've spoke about in the title of the talk about bridges to React Native. And the thing is that bridges are not existing only in React Native. In fact, any other framework which is dealing with more than one language has some kind of bridge or similar things. For example, let's take a look at Node.js, which has Node.jyp to create native modules with C++. You can also take a look at Xamarin. They have the C# binding generators, and Java has the Java native interface, mscripton, which is a project to compile your C++ into JavaScript. That's something that you should definitely look at. They have mbind or web IDL. Cocos2d.js is a cross-platform development software using JavaScript and rendering everything using OpenGL. They also have bindings because they are using the engine of Firefox, SpiderMonkey. That's the engine that I used for the game with the cat. It's running quite well and it's using JavaScript. And last thing is React Native. We have the bridge. So let's take a look at what is this bridge before going back to creating native modules. So if we want to summarize what is a bridge in a React Native application, we first have to take a look at the structure of an application. It's quite simple, in fact. You have this Android and iOS folders, the index.js file that is bootstrapping your application, and your application is built entirely using JavaScript, nothing new. And the big thing with React Native is that, of course, every component that is rendered on the screen is a native one. And this is where the bridge is starting. This is the most important part of React Native. So here is how a native application built with React Native look. You have the main thread where the native code is running, and there is this JS engine thread which is running your JavaScript application. You have also a thread for each native module that is used in your application. When there is something happening on your application, on the native part, for example, when I touch the screen, the event is sent to the JavaScript engine using the bridge. So you have this bridge, which is an asynchronous queue, which is also batched, so that there are messages going from the native part to the engine. And this is done using this asynchronous bridge, and all the messages are batched so that you can the native part or the JavaScript part can handle more than one message at once. It's the same thing happening when you're dealing with a native module, meaning that where you're on the JavaScript part, you can call a function which will be serialized as JSON and sent over the bridge. And when your native module wants to call an event or call a callback back to the JavaScript engine, that it's the same thing happening, but in the other way. If you want, we can take a look at the way arguments are sent. When you're going from the native part to JavaScript, arguments are sent as JSON, as I said, and when it's the other way, you have the module ID, the method ID, and the arguments that are also sent over the bridge. And all arguments can be and are translated by the bridge, so you don't have to do any kind of transformation on your side. Even promise are supported. So knowing this, how can we write a native module? It's something that is really not that complicated because everything is written on the React Native documentation. In fact, if you have an application and want to start a native module for example, bridging into a third-party SDK, in this case, my advice is to go and read the documentation, which is on the website. So what you have to do, open Xcode, add an Objective-C file. You can do Swift too, but it's harder, and I've not tried, in fact. Then you write your method that you want to expose. For example, you can call the method to open the third-party SDK at this point. And you expose them using two macros to export a method and a module. And at the end, when you have done this, you recompile your application, and you can access to the native module from the React Native side. So when you've used the macro export module, that's the name of the module that will be available on the JavaScript side. That's it, and that's quite convenient to expose any native module that is not requiring a UI component. For UI component, it's a bit more complicated. It's also on the website, but I won't go into details. I think that in most of the case, when you have to bridge a third-party SDK, it's because it's not that popular, and in this case, it's more like something like analytics or anything that does not require a UI component. For Android, that's mostly the same, but with Java and Android Studio. So you're using there a class React blah 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 module and React package. The first one is to describe the module, and the other one, no, that's the other way. You create first a React package, to expose the module, and then the React module is exposing the function that you want to have in JavaScript. So same thing as on iOS. Once you've done it, you can use it in the exact same way in JavaScript, and that's all we want to do with React Native. Once we're done with the native part, we want only to deal with JavaScript and using the same interface as much as possible. So that's how you start a new module. And if we want to create a module and then to publish it on NPM, well, that's not so different. Even if I advise to start with your own app and then only publish it as an external module once you're done with it, because, well, your own business first and then making a bit of open source, it's not so bad. So let's first bootstrap an empty native module. I will give you a few pointers just after. Then my advice is to create inside the repository of the module an example application so that you are able to test quickly your native modules, and people are also able to just fetch your repository and launch the example app. If you want to do this, you can use a file // in your package.json to refer to your module that is in the parent directory. So you can do this inside the package.json of the example app, and you're sure that anyone who is trying the example app will use the latest version that is in the repository of your native module. And last thing is to hit npm publish. So that's the good part of the JavaScript ecosystem. With just a single command and a repository, you're able to create a new module. And I think that's a big part of why JavaScript is so popular. In fact, the most difficult part is to bootstrap the native module. And people have been doing projects and tools to create native modules. The last one is even coming with Kotlin and Swift support, so definitely check it out. And the others are quite nice too. They are a bit different, either simpler to use, or I think that they only support Java and Objective-C, but that may have evolved. So that's, I think, the fastest way to start a new native module. The other way will be to either take another module as example or start from scratch, but wait, it's longer. And what I want to do now is to go through a few tools that we can use while dealing with native modules, because when we are working with React Native, it's quite simple to debug because we're used to the Chrome debugger. But as we are not native developers, or not everyone is native developer, we're not always aware of the tooling that is available. So the first tooling that everyone can use is, of course, just to do a few console output in Java or Objective-C. It can be really useful even in production, for example, to display that some configuration passed to your native module is invalid. In this way, better have a console output so that your users are aware that something is going wrong. Please check the native debuggers. They are not so hard to use, and in fact, you can easily just set a breakpoint and then start your application. And it's in Android Studio and Xcode. It's just a matter of clicking on the line where you want to set the breakpoint, and then you can display whatever you want. So that's something that you definitely want to check if you create a native module. This tool, View Inspectors, that's something that I've discovered while using Xcode. It's also on Android Studio. Basically, you click on this small icon over there, which is not visible at all when you're not aware of this feature. And you can see every component of your application in 3D, like this, in fact, so that you can inspect the view hierarchy and see if there is something going wrong or not. I think that's the best example of the fact that React Native is native, because you're using a native tooling to debug your application, and well, that's dope. Next, so yeah, in Android you also have the layout inspector, which is doing the same thing. Maybe there is not a 3D view, but still nice to debug things. In particular, if you're creating a UI component and it's not showing, well, that's a good way to see if it's actually on the screen or not. Last thing. No, there is still another one after. The bridge profiler. I was speaking about the bridge. You can use this project called RN Snoopy, which is displaying on the left everything that is going on the bridge. So you can actually see the data that are being sent. And if you look closely, you can see a lot of manager.create view, meaning that React Native is asking the native part to create the view on screen. You have also this message queue.spy that it's a function that you can overload to, and it will be called anytime a message is being sent on the bridge. And there is the memory profiler. Here is the Android memory profiler, much useful if you're dealing with big resources like files or image. let's speak about some things that hurt when you create a native module. So for example, first thing is, here is a screenshot of a pull request on one of my native module. So I forgot to handle an exception. So when the image to resize in the module was too high, it was crashing the whole app. Not so good. So yeah, that was me when seeing the pull request. Anyway, let's make sure to handle properly the exception. Not too hard, but still something that is not done in all native modules. Next thing is make sure to check that you're not sending too much data over the bridge. I can have already congestion on the bridge, so you can use the profiler that I just showed before, Aaron Snoopy, to see if that's the case or not. I think that's not really a problem, except if you're streamlining or sending on real time a lot of data from your native parts. Last thing to check, don't send huge data on the bridge, because same thing, the bridge is only JSON, is only handling JSON data, or it's made for this. So everything that is really large, audio, files, image, keep them on the native part and just use handles, file names or anything to deal with them. Yes, you can base 64 some files, but be sure that they are really small. And last thing to check when you're creating a native module is be sure to follow semantic versioning. Otherwise, if you create a breaking change, your user won't be aware, and that's a pain. I think that as we are working with React Native, it's a framework that is evolving a lot. So you have to be aware and to check what is happening in React Native to stay up to date. I don't have good solution, because as long as the framework is evolving a lot, we have to be watching this and to be sure to update what we are doing. As there was this Airbnb thing going on, I think it's a good idea also to speak a bit about the future of the React Native evolution. So disclaimer, I'm not part of the React Native team, and I even took a few notes to be sure not to say anything wrong. And so yeah, the thing is that everything that I'm saying is part of public resources that you can find on the React Native website. So nothing new, but I think that can be interesting if you're not aware about what is planned for React Native. So first thing is that make sure to check this article, State of React Native. It was just published a few days or weeks ago by Sophie Halpert, who is the engineering manager of React.js at Facebook, and she wrote about what I'm saying basically now. And the biggest thing is that they are working on a large-scale re-architecture of React Native. The idea is to remove all this frustrating issue when dealing with native components, and they want to enable us to have a better integration with native. So how to do it? 3 points. So the first one is they're updating the threading model. It will be possible after the change they are making to call synchronously JavaScript from any native thread, meaning that you will be able using this to call native library like navigations or other things like gesture handling, which are quite hard to implement right now. Why? Because the bridge is asynchronous, and these APIs are requiring synchronous response when you're using them. So I can think about another situation when you have when your user is scrolling really fast in a big list, and the rendering is done using React.js using flat list. In this case, you can have blank parts showing on the screen really quickly, This is the time for React to react to the message going on the bridge and to send back all the commands to the native part to display your item on the list. So this can be avoided using a synchronous bridge. The next thing is that they are going to integrate the asynchronous rendering of React 16. It was introduced in React 16. It's not yet in React Native. The idea here is to allow to have multiple priority when you're rendering your application. So there are two components. The first one is the time slicing. Time slicing is to keep an app responsive. You can make a difference between rendering that is really important. For example, when you're touching a button on the screen, you want a feedback immediately. So that's a rendering that you want to prioritize above some other rendering, like for example, displaying a new component on the screen. It's okay if a component is delayed by a few milliseconds, but it's not okay if you type something on the keyboard and want to see the letter on the screen. Well, so time slicing is a way to chunk the work being done by React. The other part of the asynchronous rendering of React is called React Suspense. So maybe you've seen the talk of Dan Abramov, who is a member of the React.js team. So he's explaining quite well, the link is also on the slide, how React Suspense is working. It's not a new API, it's just that using React Suspense, React is able to stop the rendering of any component when you want to fetch data. And you can specify a placeholder UI that is shown in case the rendering is not done fast enough. So for example, if you want to fetch data, usually what we do is that we display a spinner on the screen. And if you want to display another data on another part of the screen, if it's a different API call, we display another spinner. The idea here is to be able to launch these two requests and then have a kind of try-catch to wait for both requests to be handed and then to display the data. If it's not the case, then after a few milliseconds, React will display the spinner. So if your data connection is really fast, the app feels synchronous. But if your network is slow, then your app still feels responsive. That's something that is, the implementation is really interesting, and I will really advise you to take a look at Dan Abramov talk, because he's explaining everything in details, and that's something that is really making React having a big step in front of the other UI framework, I think. All of these are built on React Fiber, which was a re-implementation of the React core that was done last year, I think. And it was done entirely without any change in the API. Last thing that they are working on is to have a linear bridge. So the idea here is to avoid all the overhead that you have when sending message on the bridge, so as to have faster answer and faster communication between JavaScript and the native part. I don't have much details, but I guess that is all this improvement that will make React Native feel more native, of course, but also a better fit for hybrid application where you're using both React Native and native components, which was, for example, the case on the Airbnb application. Again, all of this is public, so feel free to go on the React Native website and see everything. And I think that's all. Thanks.